Hello! Today we're going to learn some math. I'm on the barbercraft server. I'm Efulton, or you can just call me Jake if you want. And what we're going to be learning specifically are certain types of gates or functions, whatever you call them. They're used in programming or certain calculus class, depending on what you're taking. They're also kind of helpful with redstoning. This server, just as a disclaimer, this isn't the most compact way to make a gate if you're doing redstoning stuff, because I'm not using repeaters or diodes or comparators, anything like that. It's just pistons, redstone blocks, and redstone. Obviously this lamp as an indicator. So things are kind of bulky, and I could have made things simpler than they are. Well, let's get started. So this first one is an AND gate. Pretty much what that means is if both of them are true, and gates work off of a true false basis. So you take one output, it can be either true or false, or one input, it can be either true or false, and another input, it can be either true or false. Takes those and gives you an output, which is indicated by this. And throughout my examples, off is going to be false and on is going to be true, which is the opposite of false, so you should probably know that already. Okay, so let's get started finally. So if this is false and this is false with an AND gate, neither of them are true. So obviously this isn't going to turn on. This is going to be false. But let's just say turn this one on. Well, the other one is false. So since both of them are not true, this is going to stay false. So let's say take that back, and I'm like, well, what if I put this one? Well, since this one is true and this one is false, still going to be false since they are not both true. So let's take this one here and make it true. And as you can see, I made it true and it lit up because P is true, Q is true. Mind your P and Q's. Both true, this is going to be true, and that's what an AND gate does. Next one, another fairly simple but very different one, is going to be an OR gate. Now pretty much what this does is if either of them are true, P or Q, the other one can be false. They don't care what the other one's doing. Other one can be false, and this will light up. As long as one of them is true, that's going to be true. And let's demonstrate it. So this first one, let's turn that on, and it's true. It lights up. Both back to false again, and it's showing up false. Let's press that one, and it is true. Look at that. This one's true, so that's true. Now, just like the AND gate one, let's put both of them on. And it is still true since either or are true, and, well, both of them are true. So, obviously, it's going to be true. No? So, we're going to skip over this one, which is complicated. I'll get back to that. Best for last. Let's go to this one. Woo! This is fun. So pretty much what this means is if P, the state of P, is equal to the state of Q, this one is going to be true. It's an equivalent gate. So that's what it does. If P is equivalent to Q, then it's going to be true. P equivalent to Q, then it's going to be true. So let's test that out. So P is false and Q is false. Now, false is equal to false. Now, would you look at that? That light is on because both of them are equal. Now, let's make them unequal. And look, that's unequal. That one's true. This one is false. And that light is not on because P is not equal to Q. So let's try that again. Both of them are false. This one is true because they're equal. Let's make this one true. And Well, would you look at that? Because I made this one unequal to that, this is going to turn off. This is going to be false. Now, just like with the first two, we're going to turn them on. Turn them both on at the same time. And since P is equal to Q, P is true and Q is true, and we get this light, it turns on, and it is in fact true. Look at that. That's amazing. This is so great. Don't you love this? Obviously, I was using pistons for this, and like I said in the beginning, there's better ways to do this that you can actually include in redstone builds if you want to use a gate. This next one, or this last one, I'm telling you I'm saving the best for last, is an implies gate. Now, this is really, it's more complicated to explain, so I'm going to attempt to explain it in Minecraft terms. So let's do this. So let's say I say something like, if you wear armor, you will survive a creeper explosion. How do you know that's true? Well, let's, I don't know. This pretty much is the process of testing that out. So let's say P is the variable of you wearing armor. So if it's on, or if it's false, right now you're not wearing armor. And if it's on, you are wearing armor. And Q is if you survive the creeper explosion. So false is not surviving that creeper explosion. You died. You're dead. Sorry, man. Better luck next time, I guess. And then put it on. You survived it. Great job, man. Props. Okay. And pretty much what this gate does is it determines whether you can prove the statement that I said true or false. And if you can't prove it false, then this thing is going to show up true. So I know it's still kind of like confusing right now since a lot of words, all that sort of stuff. So I'll try to demonstrate it and show you. So hopefully you can understand it. So let's say you do not wear armor. You're not wearing armor. You didn't survive that creeper explosion. Well, right now you're thinking, maybe I should have taken that person's advice. Maybe you shouldn't have taken my advice and worn armor, because you could have survived that creeper explosion. So you're thinking, wow, what he said was true. That could definitely be true. And as you can see, this is true. That's what you're thinking. Wear armor and survive creeper explosion. Well, that's what this is saying too. Now the next one, say that you do not wear, or say that you do wear armor and you don't survive that explosion. You're calling me a liar. I'm just like, I was lying through my teeth. You wore armor, you did what I said, and you died. And I'm a horrible person for telling you that. You shouldn't have taken my advice. I'm sorry. And because what I said earlier was false, that wearing armor would prevent dying from creeper explosions, you're like, that's totally not true. And that's what this light is saying. It's saying it's off. It's saying that is false. You're lying. Now, let's say you do wear armor and, hey, well, survive that explosion. I was right? I think I said this already. That's true. What I said earlier was true. Wearing armor does, in fact, prevent creeper explosions. Now, here's where things get a little shaky, and why earlier I said it demonstrates whether you can prove it wrong or not. And you'll probably debate me in the comments, depending on how many people comment, whether this analogy makes sense. But let's say you don't wear armor, not wearing armor, and you are just an amazing person. You're strong, you're fast, you can stop a train in its tracks with your bare hands, and you survive that creeper explosion. Well, if you can see, this is still on. Because you can't really prove the statement that I said false. Because if you did wear armor, you're as tough as a train. You're going to survive that creeper explosion too. So me saying, if you wear armor, you'll survive a creeper explosion, that's also true. That's still true. You're strong without the armor, but wearing armor, you'll still survive that creeper explosion. And that's pretty much the logic behind this implies gate. And this little imply symbol. So I hope that wasn't too confusing, and I hope I didn't mess up too bad and teach you the wrong thing. But that's pretty much these 4 gates. There's more gates. There's definitely more gates. And I might cover those in another video. We'll just see how that goes. So, again, I'm on the barbercraft server. I'll link the IP and the address and where my plot is, so you can maybe check this out and play with the levers yourself if I'm on here. Anyway, well, see ya.